If you study the Bachelor of Technical Computer Science at the University of Twente, you will notice a particular organization of the curriculum. This is called the Twente Educational Model, or TOM. We are using the Dutch acronym, which is why we never talk about TEM. In this video, I will explain the setup and rationale behind it. Why TOM? Any academic bachelor in computer science, all around the world, pretty much shares the same topics, even though the balance may differ from place to place. After all, if you have a bachelor degree, society expects a certain skill set on a certain minimal level. So the content of our program is, to some degree, prescribed and fixed. What is not fixed is how we organize it. Once upon a time, our computer science program was like any other in the world. We had courses on math, programming, design, architecture, networks, security, data, interaction, as well as a minor and final projects. All were 5 or 10 EC, and they were distributed evenly through the 3 years of the bachelor. Students could study them in order if they wanted to be finished in 3 years. If they missed a course, they could always do it later at the cost of some study delay. Guess what? About 5% of students did finish in 3 years, and many students decided they could always do the math parts later. We had students who finished the entire program except for some first and second year math courses, and who eventually left the university without diploma, because without the context of the rest of the program, just finishing those pesky math courses, which they didn't like in the first place, was just too hard. More importantly, from a content point of view, there was little coherence in the program. This was partially due to the lack of coordination between the different courses. Neither the students, nor indeed the teachers, made explicit connections between different topics, because they were too much distributed over the years. Partially, this was again due to the fact that even though the nominal program dictated some order, students back then were just as creative as you are, and many preferred their own choices. Tom changed all this. We grouped courses with related topics together in a module and added integrating projects so that you would directly apply what you learned. One module is 15 credits and takes 1 quarter. Very importantly, we made the modules atomic, so that it is not allowed to do one part of it this year and the other the next. You have to learn everything in context and are asked to master the content of a single module in one go, hold it together in your head during 1 quarter. Teachers of the different topics know what else you are learning at the same time, and in doing the project you can draw upon the fresh insights that you have recently gained within the same module. Guess what? The number of students who finish in 3 years rose up to 30%. Still not great, but an enormous improvement. Of course, if you do fail a module, you have to repeat it completely the next year, and it will then not be possible to also follow the module of the year you are actually in. So study delays certainly still occur. But since we also offer the final 2 modules twice a year, that is not shown in this animation, the average study duration is much improved. But wait, if it was all such a success story, why is there now TOM 2.0? Well, the integration of the modules was never perfect. And moreover, the reasons why big atomic units seemed such a great idea in the first place started to be forgotten. Mathematics is taught in its own rhythm and cannot always be connected to the computer science core of a module. The disadvantages and apparent illogic of having to redo topics that you already proved to have mastered loomed larger and larger. These factors combined in the decision to split off the math parts of the modules. In TOM 2.0, these are separate study units, no longer integrated with the computer science core. With respect to that core, however, we strongly believe that the all-or-nothing nature of the integrated modules was always a large part of what made TOM work. So our decision has been, let's exempt math, but by all means, let's hold the rest of the modules together. That is where we are now. And that is why TOM.